We already talked about finding, evaluating the function at a certain point. We talked about domain and range. We talked about all these things. Finding the values for which it's 0, increasing and decreasing, and the max and min. That's kind of where we left off. So if I want to find, I don't need answers yet, but if you're going to find, evaluate, and what do you do there? If it says find f of 1, what do you do? Locate where x is 1 and then give me the y that matches it, right? Okay, domain goes where to where? Left to right. Range? Good, other way around. Bottom top, right? You always want to go smallest to largest. And then you're using interval notation there. God bless you. Then we talked about for finding the values for which f of x equals 0. What does that mean? Where are the zeros on a graph? X-intercepts, okay? Not y-intercepts. This time there is one that overlaps, but be careful because it's not y-intercepts, it's x-intercepts. Remember, roots, solutions, zeros, and x-intercepts are all the same thing. Then it says increasing and decreasing for those you're moving from left to right. If it's falling, it's decreasing. Decreasing, if it's rising, it's increasing. And again, that's an interval notation. And then all the max and min. Relative, remember, you can have more than one. So the relative max is a peak. The relative min is your valley. And when you give that answer, you're going to give it an x, y coordinate form. Okay? Okay, so for number 1, when it asks to find f of 1, what would your answer be? Okay, careful and make sure you know, look at the intervals on this one, right? These are not the ones, the x-axis is going by 1s, but the y is going by 2s. So where x is 1, y is actually what? 2. Okay, then it says find f of 2. So x would be 2 here. What's your y? 4. Then it says domain and range. So as I go from left to right, what values are covered for my domain? Mary Angel. Good. Those arrows, although they're increasing small increments left to right, they are still continuing on. So it's going to be negative infinity to positive infinity. And then for range, same, right? Negative infinity to positive infinity. Questions on that one? So if it had stopped short, let's say it had stopped there, then I would have said, well, around negative 6. Negative 6 to positive infinity. Okay, and then my x's would have stopped at I don't even know what that's, 3.2 as well. So just watch. If it goes off your graph, you're assuming that it's arrows. If it doesn't stop, if it stops short, obviously then you're looking at those endpoints. Number 4 says to find the values for which f of x equals 0. So we said this is where it crosses the x-axis, which are at what point? 0 and 3. And you give those as the answers, not 0, 0, not 3, 0. You want the x values for where it's crossing the x-axis. So you want the 0 and the 3. 5 says state which intervals the graph is increasing or decreasing. So this is kind of where we left off yesterday. We didn't get a chance to work through an example of it. If I'm going from here to here in a downward motion, that would be what part of the graph is doing what? Or that part of the graph is doing what? Decreasing. Okay, so how do I reference that part of the graph? Negative infinity, good. Up to 0. So it's the x values for which it is decreasing, which would be, so it's decreasing. Negative infinity to 0. Now does 0 get a bracket or a parentheses? Bracket. Why? What happens after that point? What happens here? It's increasing. Where does that increase start? 0. Can a point be increasing and decreasing at the same time? Nope. So these get parentheses. Okay? Increasing and decreasing will get parentheses except for one exception, and that is if it starts or stops constant. So if your graph went like this, these 2 points are the only points that you're going to see with a bracket. Okay? Everything else gets a parentheses because a single point cannot be both increasing and decreasing. A single point can be constant. So like this one, let's say this was, I don't know, let's say this one like this, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. Then I would say that this is constant from negative 3 to 2. Oh, not there. -3 to 2 with a parentheses. And then it's increasing. Good morning. Thank you. Increasing from 2 to 3, roughly. It's not the best scale. And then it's constant again from 3, 4, 5, 6, 7 to 7. So that's the only time you're going to see brackets on increasing, decreasing behavior is if it starts or stop constant. Everything else is a parentheses. Does that make sense? Yes? Okay. So if I go back to the one we were working on, it is increasing from 0 to 2. And then it starts decreasing. And then it's decreasing again from 2 to what? Good. 2 to infinity.
Do you want us to put like the U in between?
It doesn't matter. You can list it or you can put the U. It's the same thing. Yeah. I actually don't remember how it is on website. I have to look at the format on it. Yeah. Questions so far? All right. Then it says state relative max or min values. So remember, every time it goes up and comes back down, like here, that's a max or a relative max, which would be 2, 4. And everywhere there's a dip and it goes back up again, that's a relative min, which would be 0, 0. Questions? Okay, so we're going to pick up where we left off yesterday and continue with 1, 3. So we left off on this graph, okay? I'm going to try to record on this. Okay, so yesterday we left off here, right? We plotted this graph. We went to our y equals. We typed in -2x squared minus x. And then we hit graph. And the window was originally here. Let's see. It looked like this. And the top part of my graph got cut off. Remember this? Yeah? Okay. Then we said you have two options. You can either zoom out or you can adjust your window. Zooming out brought really far out that it was hard to read. So we said it's only a little bit at the top there that's getting cut off. So I'm just going to adjust my Y max. I made it 12. And see if it'll catch the up and down, which it does. Then we said there's two ways to find the max. You can either trace your graph and watch your Y values go up and come back down again. Okay, but the more exact way and the easier way is to use that second trace, which is calc. So if I go second trace, I get the calc menu. I go down to maximum. I want to go left of the peak. Anywhere left of the peak, so somewhere over there, hit enter. Then it wants my right bound, so I have to go right of that peak, anywhere right of it. I hit enter. And then it says, are you ready for me to guess? And I am, so I'm going to hit enter, and it's going to bring me directly to that point, which is your max. So if I look at that point there, it's negative 2.2499. So I'm going to round that to negative 2.5. It will tell you on your test what you're going to round to. And then 10.125. So you will get something on your test that you are not able to graph by hand, that you'll have to answer questions like kind of like what we did. What are your max? What are your mins? What is your increasing? What is your decreasing? What is your mid, domain, and range? So one, you got to be comfortable enough with your graphing calculator. Well, one, you have to have a graphing calculator. Okay. Two, you got to be comfortable enough to be able to graph whatever it is. Three, get the information that you need from it. So if I wanted the zeros of this function, I can go back to that same menu and I can go to 0. And it's doing the same thing because it's crossing the axis twice. It's saying, which 0 do you want me to find? So if I go left of the first 0, right of the first 0, and hit enter again, it's going to bring me to the first 0 there on the left. And then I would do it again, so that's 4.5. Do it again for the second one. This time I have to go left of the next 0. Oops. There's my left. I have to go right, which this time is under it, and then guess, and it will bring you directly to your zeros, okay? So you want to be comfortable doing that because that's going to help you, one, if your direction's changing, you need to know where your max and mins are because that's where your increasing and decreasing is going to stop, right? And then you want to be able to find your zeros without having a function because you may not have one that can be factored to solve. Does that make sense? Yeah? Okay. All right, the next thing we get to is piecewise function. So these we will do by hand. When you're graphing a piecewise function, Remember, piecewise means it's different for different values of x. Okay, so there's two different ways to do it. I'm going to teach you both ways, and then you decide which one you want to do. Okay, one way, and we'll start kind of basic, is to graph them both and then erase what's not in the range. Graph them as though they're independent of each other and then erase what's not in that range. So if I look at the first one, if I graph y equals 2x plus 3, what kind of graph is that? A line. I'd start at positive 3. I'd go up 2 and over 1, and I'd draw my line. The second one would be y equals 3 minus x, sorry. 3 minus x, so in slope-intercept form, that's negative x plus 3. So I do the same thing, start at 3, start at the y-intercept. This time my slope's negative 1, so down 1, right 1, and I draw my line. Now, if I left it like it is, it fails my vertical line test, which means it's not a function and it has to be a function. So I know there's some sort of restriction set in place. That's what the second part of this tells you. So for the first one, it says that it is that red line is the 2x plus 3, where the x values are less than 0. So I'm going to go to that red line. I'm going to say x is 0 here. Less than means what kind of dot? Close or open? Open. So I want an open dot, and less than was what part of this graph? The left side of the graph or the right side? Less than 0. Left or right? Left. So that's this part, which means I'm going to erase this part. And with your partial erase now on Notability, makes life easier. Now the second one says that that equation is true where x is greater than or equal to 0. So greater than or equal to tells you what? Solid dot. And which part of this graph is greater than or equal to 0? Right or left? Right. So it's that part, and I'm going to erase this part. So there's an overlap on that dot, which ends up making it a solid dot. That's fine. Sometimes they will not be the same y-intercept or the same point. And if that's the case, if like that green line was one up from the red line, one of them must be solid and one of them must be open. You can't have two y's with the same x. So one of them would have to be solid, one of them would have to be open if they were not the same dot. Questions so far? Okay, second way to do it is plug in some points. With lines, honestly, I think it's probably easier the first way, but it's up to you. Okay, when you get into graphs that you're not sure what they are, the plugging in the points is going to be better. Okay, so what I would do is I would take that first one, which I'm going to say is that y equals 2x plus 3. I'm going to plug in points from the range it gives me, whether or not it's an equal to or greater than or equal to or less than or equal to. I still want to use the value that they gave you. I just know that that's going to be an open dot. So I'm going to start at that dot, which in this case is 0, and it's less than 0. So I'm going to work my way back like -1 and -2. And then I just take them and plug them in. So 2 times 0 plus 3 is 3. 2 times -1 plus 3 is 1. -2 times 2 is -4 plus 3 is -1. And then I plot these points. 0, 3, but that's an open dot. -1, 1, -2, -1. And it would continue on and out. And then I would do the same thing for the second one. Y equals 3 minus x. This time I'm starting with 0, and I'm going greater than it. So 1, 2. 3 minus 0 is 3. 3 minus 1 is 2. 3 minus 2 is 1. 0, 3 is a solid dot this time. 1, 2, 2, 1. My graph would continue in that direction. So you can choose, again, if you want to graph and erase, because you'll have a pencil and an eraser. Or if you want to plot points, And honestly, I would be comfortable with both because sometimes it's easier to do one over the other depending on the type of problem. Does that make sense? Yeah. Okay, so again, you can choose in which you do this. If you're going to graph and then erase, or you're going to like plot points. For the lines, I would say it's probably easier just to graph it, but if you want to plot points, go for it. So if I said 2x plus 1, I would start at my 1, which is my y-intercept, and then I'd go up 2 and over 1, up 2 and over 1. And this is for where it is less than or equal to negative 1. So as you work your way back, your less than or equal to negative 1 happens here, and then you would draw everything left of it. So I don't need any of the points on the right-hand side. I could have also plot points, again, starting with negative 1 and working my way left. Then my parabola, we haven't gone over transformations, but if you're comfortable with transformations, use them. That's a parabola that's shifted down 2 places, okay? But in order to get exact points, you're going to want to plot your points, because unless you know, you'll know the vertex from your transformations, but you won't know your other points necessarily. So if I do that, if I graph where x is greater than or equal to negative 1, I'm going to do negative 1, I'm going to do 0, I'm going to do 1. And then I plug those in. Negative 1 squared minus 2 is 1 minus 2, which is negative 1. 0 squared minus 2 is negative 2. And then 1 squared minus 2 is negative 1. So now I know that this is an open dot because it's not an or equal to. So negative 1, 1 for this part has my open dot. Those still overlap. 0, negative 2, and 1, negative 1. I know I'm moving up in this direction, and I know it's going to be a parabola, so it's going to have that curve. Yep. A piecewise function on your calculator. So there's a couple ways to do it, but one way is to put a fraction in your y equals, and to do that you have to go into, let me remember, alpha y, and you get this little menu that says n, d, and like all that stuff. You want to go to the first one, which is numerator denominator, and it separates it out like this. And then you want to type your actual function in the top. So 2x plus 1 goes in the top, and then your interval on the bottom. So x is less than or equal to negative 1 in this case. X, the less than or equal to is under your test menu, which is second math. Less than or equal to negative 1, hit enter. That's your first one. And then I'm going to repeat that again for the second one. So alpha y equals n over d, x squared minus 2, enter. Go to the denominator on that one. Sorry, I didn't go to enter. Should have gone to the denominator. Okay, x, this time is greater than, go back to test. So that's second test, greater than negative 1. Enter, graph. Wait for it. Now what you won't see is open dots, solid dots. So you gotta be really careful on that, okay? You gotta know by looking at it which one's supposed to have a solid dot, which one's supposed to have an open dot. Okay, but at least you can see them both in one graph. You won't have to do that for your test. That is merely just to help you check your answers, okay? But it is an option to do it that way. Talk about this, and then if I should be able to go back and actually show you how to graph those piecewise functions on your calculator. All right, so even and odd functions are based on their symmetry, okay? A function is even when for each x in the domain of f, f of negative x goes back to f of x. So if what's inside this parentheses is your x values, when else do we use the test to change x to negative x and see if it goes back to the original? Symmetric to which axis? Y. So an even function is symmetric to the x or to the y axis, sorry. An odd function is if you plug in negative x and it changes the entire thing. So this is like saying a negative x would result in a negative y. When do we change both negative x and negative y? Origin. So odd, origin, even y-axis. Same thing. This says what we just talked about. So from a graph, the even function, or a function is even when the graph is symmetric to the y-axis, and from a graph, the function is odd when the graph is symmetric to the origin. So remember, y is obviously where we're going to be able to flip over to the left. And then origin is where you can like flip down and over, something like that, where you can flip down and over, it will overlap. Why do you think there's nothing about it being symmetric to the x-axis? And it wouldn't be a function. Good job. Right? If I flip it over the x-axis, it would fail my vertical line test, and it would not be a function. All right, so we graph the function. Okay? It looks like this. So I'm going to take a snapshot of it, but I'm also going to pay attention because I need to know where that max and min is happening, right? So I'm going to go to second, trace. I'm going to go to that max. And this one takes me straight to it because it's nice and easy. I didn't even need left bound, right bound. But if I did, I'd go left. I'd go right. I'd say guess. It's going to bring me right there. So that 1.858 e to the negative 10, or negative 6 is scientific notation. It means 0.0000001. What's that going to round to? 0. Okay. So my max, I know, is at 0, 4. That's going to help me with my x. That's going to help me with my max. Obviously my max is up. It's going to help me with my increasing and my decreasing, right? Because that's where it changes direction. The other piece of information, it's going to help me with my domain and range, because it's going to give me my range, right? The other piece of information I need to get from this is my zeros. So I'm going to do it on the calculator, and then we're going to do it without the calculator, because you're going to have to learn how to do that too. But I'm going to go to second, trace. I'm going to go to my intercept. I'm going to go to my zeros. It's going to ask me which one do I want to find first. I'm going to go left of the line, right of it. Guess, that's negative 2, which is where it looks like it. And then I'm going to do it again, second, trace. I'm going to go 0. I'm going to go left of it. I'm going to go right of it. And I'm going to bring it to the middle, and it's also positive 2. Now I pretty much got every piece of information that I need from that graph, from my graphing utility, right? Okay. So I kind of did it in reverse order, but we're also going to have to graph some of these by hand, right? So something like a parabola, I'd expect you to be able to graph by hand. The more complicated they get, you'll see, you'll have to use your calculator. That's when it will make sense, okay? But to graph this, I could have simply just plotted points, right? If you don't know what your parabolas look like yet, because we haven't reviewed transformations, which we will, I could have done negative 1, 0, 1, and seen if that gave me enough information. So I'd get 4 minus 1, which is 3, 4 minus 0, which is 4, 4 minus 1, which is 3. So I get these points here, but I need my zeros. I need to know where it's crossing that x-axis. So how can I find them? Set it equal to 0, right? The same thing as getting your y-intercepts. So I would say 0 equals 4 minus x squared. Add the x squared, square root both sides, reminding myself to do the plus and minus 2. Now I have my intercepts, which are the zeros, which is part of what it's going to ask you for. So you got to make sure you'd be able to know how to do that with and without a calculator. So by looking at it, can you tell me if this is even or odd or neither? It's even. Why is it even? Symmetric to the y-axis, so this is even. B says the interval for which f of x is greater than or equal to 0. So greater than or equal to 0, the y, right, because that's f of x. Where are those points on your graph? Where would the y values be greater than or equal to 0? Where's y positive on your graph? What quadrants? 1 and 2, the top part of my graph, right? So anything of this graph that's happening from this line and above is greater than or equal to 0. Do we agree on that? Yes? So how, in this case, how would I explain this interval? How would I give that? What's the smallest x? Negative 2. What's the biggest x? 2. It's going from negative 2 to 2. Is it including negative 2 and 2? Yeah, because it's or equal to, right? So this would be negative 2 to 2, bracket on both. Now let's go back and talk about all the stuff we said we were going to talk about. Domain on this graph is what? All real numbers. Negative infinity to positive infinity. Range.
Negative infinity to 4.
Good. Negative infinity to 4 is 4 part of the graph? Part of the range? Solid dot? Yes, so it gets a bracket. Questions on domain range? Okay, increasing, decreasing behavior. So we start from left to right. The first part of this graph is doing what? Increasing, right? Increasing. I do the x values. So from negative infinity up to 0, my graph is increasing. Parentheses on the 0 because a point can't be increasing. Then it changes direction. It comes back down. It's decreasing from 0 to positive infinity. Again, parentheses, because a point can't be increasing or decreasing. We found our max, right? We said our relative max was 0, 4. What else did I miss? Okay, there's no relative min, right? It never goes down and comes back up. I'm missing something else, right? Oh, the zeros we said were negative 2 and 2.
What's supposed to be your interval?
What do you mean?
What is it? Because I thought the decreasing and increasing was like an interval. Like I know last week that was like.
It's an interval notation. Is that what you mean?
Yeah, like the
Yeah.
you said like the interval was.
So it's domain, range, and increasing, decreasing are interval notation.
No, like you know the part that you said like the part where you highlighted everything.
Yep.
Like what is?
Oh, that's saying for what values are f of x greater than or equal to 0. So it's saying for what values are your, because f of x is y, right?
Mm-hmm.
So it's saying for what values of your graph are your y's positive. If it had said less than or equal to 0, if it had said for what values are f of x less than or equal to 0, now I'd be using these ranges down here. So I'd be saying from negative infinity, negative infinity to 2, negative 2, bracket, because it's or equal to, and so the union, 2 to positive infinity. If this graph pointed up, then it'd be the reverse. Like if it pointed up, then everything below it would be less than, right? And everything above it would be greater than. So f of x greater than is saying where is it positive? Where are your y values positive? And then f of x less than would be where your y value is negative. But all of those answers are based on your x values. The only thing based on that has a y value is your range, and then your max, obviously, or your min has partly of the y value.
Wait, so what's the negative 2?
That would be if it had said, find the interval for which f of x is less than or equal to 0. Questions? You have to be oh so careful on this kind of question, because if you graph it wrong, guess what happens? Everything after that is wrong. It's a compound question. It's going to be based on, there's one based, you're going to have to graph by hand, obviously, but you're also going to have one based on your calculator. So you have to be really careful, because if you get something wrong on that graph, it steamrolls into every question after it.